Okay, hey guys, let's look at this part C for your monohybrid cross practice. Let's look at 17. So we have a hornless, or I guess hornlessness, not having horns in cattle. Cattle are cows, so C-O-W, is dominant over having horns. So if a cow doesn't have horns, or if a bull doesn't have horns, it's a dominant trait. Having horns is dominant, and not having horns is recessive. So a homozygous hornless bull. Homozygous, same, hornless. Hornless is dominant, so if it's homozygous hornless, it's is mated with a homozygous horned cow. The cows are female. Homozygous horned, homozygous, right? Okay, so you have big H, crossing with little h, little h. You have homozygous dominant crossing with homozygous recessive. So let's predict their babies. We can predict the babies using a Punnett square. So it doesn't really matter. Let's put big H, homozygous dominant on the top, homozygous recessive on the side. Okay, here. Okay, there you go. Now, the genotypes and phenotypes of the first generation. So here are the parents, and here are the babies. This is the first generation. Okay, so the genotypes of the offspring. I'm just going to put G for genotypes. Is 100% homozygous, 100% heterozygous. Okay, this baby is heterozygous. 4 out of 4 are heterozygous. The phenotypes, P for pheno means physical. So what are they going to look like? Well, what's the dominant trait? The dominant trait is hornless. So they're all going to be hornless. Okay? So I'm going to do one more for you, and then the rest is on your own. Let's look at number 18. In tomatoes, red fruit is dominant. So capital R is dominant over yellow fruit, yellow fruit is recessive. A plant that is homozygous for red. If it's homozygous red, it's homozygous dominant, because dominant is the red phenotype. Okay? So there's homozygous dominant. So a plant that is homozygous for red fruit is crossed with a plant that has yellow fruit. The only way that a plant can have yellow fruit, the only way that a tomato plant can have yellow fruit in this example, is if it is homozygous recessive. Because think about it. If you have big R, little r, what kind of fruit is that going to be? It's going to be red, because red is dominant. So the only way you can get yellow fruit is if you have homozygous recessive. So the question is, what would be the genotypes and phenotypes of P1 and F1 generations? Well, here are your genotypes of P1. Homozygous dominant, homozygous recessive. And your phenotypes you already know. Red, yellow. So you're going to have red and yellow. Okay? Now, so then it says, what's your F1 generation? Remember, F1 is your offspring. So let's do a Punnett square for this cross. Okay? Big R, homozygous dominant, and homozygous recessive. Okay, these are your offspring. So the genotype, the genes, the letters, genes are the alleles, genes, okay? So when it says genotype, it's talking about the alleles. What letters does the individual have? So your offspring are going to be 100%, the genotypes of your offspring are going to be 100% heterozygous. Again, I'll put G for genotype. The phenotypes of the offspring, What does phenotype mean? Phenotype means what it looks like. Okay, what color of fruit is this one going to have? Well, it's heterozygous. What's the dominant trait? Red. So it's going to have red fruit. Heterozygous, heterozygous, heterozygous. They're all going to be 100% red. For the rest of these questions, you cannot copy what I've done here. You have to read very carefully and look at what the question is asking. 2 of the F1 generations from the above cross. It's talking about this. So 2, 1, 2. 2 of the F1 generation were mated. They had babies. What are the genotypes and phenotypes of F2? So you're going to do a Punnett square for the offspring. Okay? All right. Good luck. If you have any questions, email me.